Welcome back to Electrical Point. In this video, we will discuss the classes of motor duty. First, we have to know what is motor duty. We know that the operating time and the type of loading is different for different type of motors. These are basically decided by the application for which the motor is being used. Therefore, the concept of motor duty is introduced. Some motors may run continuously for a long time, while others may run for a short time. Some may even run with continuous braking and starting. All of these load cycles are basically defined by the motor duty. Okay, there are eight standard classes of motor duty from S1 to S8. These are used to select appropriate motor rating for a given application. We will discuss them one by one in this video. The first one is continuous duty, is also known as S1 duty cycle. The motor operates at a constant load for a very long time. As the name suggests, the motor operates at a constant load for a very long period. From the graph, you can see that the load is applied at this point. Okay, now the temperature starts to rise in the motor, and after some time at this point, the temperature of the motor attain the steady state value of the temperature, that is the theta max, and after that it continues to be at that value. Some of the example of this type of motor duty is pump, paper mill drives, compressors, etc. The second one is short time duty, also known as the S2 duty cycle. Here we can see that the load is applied for a very short time, only for this much time the load is applied on the motor, and at this point when the switch is turn on of the motor, the temperature starts to rise, and before it reaches its steady state value, it again drops to the ambient temperature because the motor is switched off at this point. It is due the temperature does not reach to the steady state value because of the operating time is very less than the heating time constant of the motor. Okay, we also know that there is a time lag between losses of the motor and resulting temperature rise. Therefore, this motor in this duty cycle can be overloaded for a very short time. A good example of such type of motor duty is that is used in mixer grinder. Okay, we do not use it for a very long time. We use it and then switch it off. Coming to the third type, we have intermittent periodic duty, also known as the ST duty cycle. It is characterized by consistent loading and followed by rest operation. Here, for this time period, we have loaded the motor. It is loading. Then during this time, from here to here, it is rest period. Then again the motor is loaded. Then again there is a rest period. But these periods are very small to attain steady state temperature. It even does not cool off to ambient temperature. At this point, when the motor is switched on, the temperature rises, but does not attain the steady state value. That theta max is less than the steady state value, and again as it is cut off, the supply is cut off, it start to decrease, and before it reaches the ambient temperature, it again increases due to the as the supply is again given to the motor. Okay, so a good example is lift. We use the lift, then there is a rest period before someone else use it again. Okay, now coming to S4. S4 refers to intermittent periodic duty with starting. What happens is that in some very heavy motors like that are used in oil well drilling, the starting current is very large. We can't neglect its effect. If proper insulation class is not selected, then the heavy current may damage the insulation. Therefore, temperature rise during starting cannot be neglected while selecting a motor rating. Okay, you can see the temperature rise is more. It is this period refers to starting. Okay, then this is loading and this is the rest period. Therefore, I have stated here that there is a starting period, loading period, and rest. These are can be seen in this graph. In the starting, you can see that the temperature rises more because the current draw by the motor is very large. After that, it decreases. Now the currents come back to the normal value that is required for this type of this loading, and at this point the supply is cut off. Therefore, it start to the temperature starts to decrease, but the rest time is not sufficient to reach the ambient temperature. This is less. This is the rest time. This is very less to reach the ambient temperature. Therefore, again it start to increase at this point when the starting current is there, when you switch on the motor again. Okay, this happens in periodic cycles. Therefore, it is intermittent periodic duty. Okay, as I have already told, some examples are a good example is drilling tools. It uses very heavy motors that draws very heavy current during starting. The braking is neglected because mechanical braking can be used in this duty cycle. Okay, the next one is S5 duty cycle, that is intermittent periodic duty with starting and braking. This is basically same as that of the previous duty cycle, but here the braking is carried out electrically. Okay, in case of VFD motors that uses electrical braking. Okay, therefore you can see that there is a starting period. This is starting period, this is loading period, and this is braking period. The power is negative, refers to the braking, but the losses will be there. It will be add up to the already loaded losses. Okay, at this point. Therefore, you can see that the temperature rises more during the braking, and you can't neglect it. This is the curve. These cycles repeat. Therefore, the intermittent periodic duty, as the name suggests, all periods are too short to attain respective steady state temperature. Okay. Next is S6, that is continuous duty with intermittent loading. It is almost same as intermittent duty, but the only difference is that supply is not cut off during the rest period. Therefore, the no load losses will be present continuously. You can see from the curve that this is the loading period, this is rest period, and this is loading period. Again, the load is applied intermittently, but during the rest period, as the supply is there, the no load losses will be present. This is the no load loss that is there during the rest period. Therefore, the temperature rises more in case of S6 duty cycle than the normal intermittent loading. Okay, now coming to S7, we have the continuous duty with starting and braking. You can see from the curve that this is the starting loss. This refers to the braking period, and again there is a start. There is no rest period in this duty cycle. We have starting, loading, braking, then again starting, loading, braking, and the cycle repeats after this. Okay, now if we see the temperature curve, we see that the temperature rises during the starting. As the starting current is more, then again it starts to go down to the normal value that is required for that for this type of loading. Temperature basically refers to the current that it draws. Okay, so the current will be less, and therefore the temperature rise will be less, and it will come down. But during the braking, it will again go up. The reasons I have already explained while explaining the S5 duty cycle. This is for S7. Now we'll go to the final duty cycle. Now comes the S8 duty cycle, that is continuous duty with periodic speed changes. There is periodic duty cycle is running at 2 or more different load. Okay, Each cycle involves operation at a constant load and a specific speed. You can see P1 is the load and that specific speed is N1. Okay. Similarly, P2 is the load and N2 is the that specific speed for that load. Unlike other duty cycle, their motor does not have any rest period. Okay. During starting, as we have already discussed in many duty cycles, the temperature rise is more because the starting current is there. After that, it comes back to normal value for this corresponding to this load. Then there is this see this is not braking but acceleration. It can be acceleration and deceleration. If the speed increases, then we have to accelerate the motor, and if the speed decreases, and we have to deaccelerate the motor. In this case, we can see that the speed is more, therefore we have to accelerate the motor. And in case of acceleration or deacceleration, we know that the motor draws a large current, was more current than the normal operation, therefore there is a speed rise, temperature rise in this period. After that, it attained that speed N2, and therefore the temperature will try to come down for corresponding to this load P2, and again there is a period of acceleration. Okay, this is acceleration and temperature rises. Then this temperature rise, this temperature correspond to this load P3. Similarly, after this point, again we will come back to the starting. P1 load will be there, and the cycle repeats. This is the cycle from here to here. Okay. So yeah, we have discussed all the duties from S1 to S8, and that's it for this video. In the upcoming video, we'll discuss more concept related to electrical drives. We'll discuss the duty cycles more from the calculation point of view to decide the rating of a motor for a specific duty cycle. Okay. Thank you for listening to this, and hope you'll like the video. Do subscribe and share amongst your friends. Thank you.